Every year, my family and I make a trip to India, and every time we go there, I witness some of the extreme water conditions that people have to bear. But the one thing we all need to survive is quality water. After witnessing the condition of water in my visits there, I was inspired to create AquaCheck, which I'm presenting for this year's Congressional App Challenge. AquaCheck serves as an initiative to efficiently mend the degraded water quality in underdeveloped regions. It's a water quality monitoring system that will use various sensors and a microcomputer to detect the pH level, temperature, and turbidity. Currently, in the present day, there are many water quality monitoring systems that serve the same purpose as what I have just mentioned. The existing systems that check the water quality are time-consuming and very expensive, ranging from $4,000 to $10,000, and it is almost impossible for underdeveloped countries to afford them. They can only be used in developed areas, but the system that I created is a low-cost, easy-to-use, and equally effective system. When using AquaCheck, you can both locally and remotely track the data output. This system makes tracking and following the data very simple and easy to check for sudden changes in the quality of water. This is how AquaCheck works. So you first place a sensor module in water. Then, the sensors send the information about the temperature, pH, and turbidity to the Raspberry Pi, and the Raspberry Pi processes the data and sends it to the web app using an IoT platform. The user can then easily see the data in a visually appealing way, and this IoT platform can also send notifications in different ways if the sensor readings cross a certain threshold. In my project, I used Python as my programming language, PyScripter as an IDE, and ThinkSpeak as an IoT platform to plot my data in real time on the web. The temperature, turbidity, and pH sensors send information to a low-cost Raspberry Pi microcomputer, which interprets the sensor output and publishes it on the web portal using IoT techniques. Having published the data on the web allows anyone, anywhere in the world to remotely monitor the water quality. One of the challenges was to amalgamate all the sensors in a module that can be immersed in water without damaging the sensors. AquaCheck is capable of handling more sensors, and I wish to add a dissolved oxygen sensor as an additional way to check water quality. All in all, AquaCheck serves as a cheap, easy to use, and highly effective water quality monitoring system that can have a great effect on people's lives in underdeveloped regions.